All right, in this video, we're going to be doing page, I don't know, 39, I guess, in math analysis. We're talking about transformations. I was a little confused on what page we're on because we're really going to fill in stuff on page 40, but I think I'm going to call this like 39 part 2, maybe. I don't know. It's either going to be 40 part 1 or 39 part 2. That doesn't really matter. So we're going to talk about transformations. Transformations are like where it's at when you're talking about trig functions. So we're going to use a specific form of the trig function. And it's going to look like this. So we're going to have an A or an A. Now we're going to have B outside of parentheses, B. And then there's going to be a C that's in the parentheses. So it's going to be X minus C in parentheses. And then there's going to be a D that hangs around on the outside. Sometimes that's initial. It's like the initial value. Sometimes it's at the end. It doesn't really make a difference. So what we want to do, so it's A sine of B, the quantity X minus C, and then plus D, which is why D is sometimes first. So it's not ambiguous, like should it be inside the parentheses, should it not be? If you say D plus A sine of B times the quantity X minus C, less ambiguous. So you'll see that sometimes. I actually do that a lot when I write my equations from a graph, because I think it's very clear that way. So this is a transformational form. What we need to do, though, is we need to figure out what A, B, C, and D are doing. So what we're going to do is we'll actually just play around on the calculator to see if we can work that out. So I'm going to switch over and see what the calculator has to tell us about this. So I'm also going to show you a couple things you can do on your calculator. So here, I'm in a new document. I'm on a calculator page. And the first thing I'm going to do is I'm going to graph sine of X. So make sure you're in radian mode. If you graph in degree mode, sine looks very bad. So here's degree mode. This is what it will look like. Why does it look that way? Well, now you're graphing in degrees. So you're graphing between negative 10 degrees and 10 degrees. Sine should take 2 pi or 360 degrees just to give you one cycle of the graph, right? The 5 key points, intercept maximum, intercept minimum, intercept, 5 key points. You'll get that in 2 pi. You would need 360 degrees, but you should only really graph trig in radians because then the X and Y axes are the same units. They're just real numbers and you can actually do stuff. So this is my graph of sine. This says to graph 3 sine of X. Okay, so I'm gonna do that. All right, so this is, it looks like a vertical shift. No, a vertical stretch rather. Vertical shift? No, vertical stretch. It looks like changing that number gave me a vertical stretch. Let me try. Like what do we go up? So 6. Yeah, so what used to be at 1 is now up at 6. The zeros are still zeros, and everything looks like it kind of shifted accordingly. One of the things, I don't really like doing this, but you could actually give yourself like a slider. I'm gonna say K, oh, well, let's say A, right? Do I want to create a slider? Sure. And now what you can move this, control click and then drag it. I don't really recommend you do this. It's not like very satisfying. Click somewhere, and then we can click on this and drag it. So when A is 1, 2, 3, 4, 5, so you can see what's happening. Now, what happens when A is negative? So it looks to me like it's still stretching it, but it's also reflecting, which makes sense because a negative coefficient is going to reflect your function. So it looks like A actually has 2 purposes. One of them is a vertical stretch. And what we say is that it's changing the amplitude. So the amplitude of a trig function is how far you can get away from the sinusoidal axis, right? So the sinusoidal axis of this is 0. It's kind of like where all the intercepts are happening. We can get 5 units away from that in either direction. So we can go up 5, we can go down 5. So A, it looks like, is doing 2 different things. What can I undo? I'd like to get rid of this slider, actually. So there we go. Okay, so now what I'm going to do is I'm going to press doc, option 4, option 1 for new problem. And then I'm going to put in another graph page. And you can see this is 1, 1. And these were functions F1 and F2. And then if I press control and to the right, now I'm in 2.1 and I can reuse F1 again. So I'm going to make it cosine of X this time. And then I'm supposed to graph -4 cosine of X, which I expect will stretch the graph by a factor of 4. So everything that was at 1 will be at 4. Everything that was at -1 will be at -4. But because I'm multiplying by negative, I'm also going to reflect. So I'm expecting like the initial maximum to now be a minimum, and then go from there correspondingly. And that's what happens. So we get a stretch and a reflection. Looks like A will stretch and reflect. So the absolute value of A is called the amplitude of your function. That's how far you can get from the sinusoidal axis. And then if A is positive, you get the normal pattern. If A is negative, you reflect your pattern. So I think I have a handle on what A is doing. So the next thing we're going to mess around with, so doc for 1, is the value of B. So B is the coefficient of X when you distribute it. So here, it's just, well, this is the wrong type of page. Hold on here. Let me get rid of this. I want a graph page. Here we go. Okay, so sine of X. Now I'm going to change the coefficient of X. So I'm changing the value of B. I'm going to make it sine of 2X. So this is one of the weirder transformations. So what is happening here? Well, let me first do this. Menu 6, new, menu, and then window. And then I want option 8 for trig. So menu 4, option 8 for trig. And you can see it changes it. So we're going negative 2 pi to 2 pi. That's kind of useful. So I'm getting, the blue one is the original sine graph. And the red one is sine of 2x. Now, if you look, you can see that you get one full cycle. So intercept, maximum, intercept, minimum, intercept. I get one full cycle in half the time, which means I actually get 2 full cycles in 2 pi. And the value of B was 2. So maybe B is telling you how many full cycles you're getting in 2 pi. Let's try changing it to 3. All right, so do I get 3 full cycles? I think I do. I go intercept, then a maximum, intercept, minimum, intercept. That's 1. Intercept, maximum, intercept, minimum, intercept. That's 2. Intercept, maximum, intercept, minimum, intercept. That's 3. So when B is 3, I get 3 full cycles. If I make it 5, will I get 5? It gets annoying to count them. But you know what we can actually do is we can count just maximums. So let's see how many maximums we get. 1, because there's 1 maximum per period. So 1, 2, 3, 4, 5. So it looks like B is telling you the number of cycles that you get per 2 pi, which means each of them is taking 2 pi divided by B. Each of these is taking 2 pi over 5 to complete. We can kind of see that. So what I'm going to do is I'm going to trace menu 5, enter, and you can just type in a number. So what I'm going to do is I'm going to type in 2 pi over 5. I think it's going to take me to intercept, maximum, intercept, minimum, intercept. It's going to end this one period. I'm on the wrong graph. Okay, there, it did it, right? Intercept, maximum, intercept, minimum, intercept. So now let's go to 2 times 2 pi over 5, which you can actually just type 2 times 2 pi over 5. Takes me to another end, 3 times 2 pi. 2 pi over 5. Takes me to the end of another one, 4 times 2 pi over 5. Another one, and then finally 5 times 2 pi over 5 is just 2 pi, takes you to the end. So B is changing the period of the graph. It's telling you how many cycles you get per 2 pi, and the period of the graph is 2 pi divided by B. So 2 pi divided by 5 in this case. Also, you can see here you get that weird version of 0 that sometimes shows up. It's got something to do with, like, I don't know, like floating point numbers or something. I don't know. That is 0. That's 2 times 10 to the negative 12th. That's a lot of zeros. That's basically 0. So that's, I think, the value of B. All right, so we got to keep track of a lot of things here. And I'm supposed to play around with another one, but I'm going to skip that because I think I know what B is doing. So I'm going to insert a new problem. Actually, I'll like graph them. So cosine of x, just so that I can yell at you if I need to. Cosine of x over 2. So this should give me, B is 1/2. It should give me half of a cycle in 2 pi. So it should take 2 pi divided by 1/2, 4 pi to get one full period. So let's see what happens. So it should take 4 pi to go maximum, intercept, minimum, intercept. I have to go back to a maximum, but I also have to change it again. So menu 4, option 8 is trig. And then I really want to change this to 4 pi. So let me do that, 4 pi. And you can see it does take 4 pi to get one full cycle of maximum, intercept, minimum, maximum, intercept, minimum, intercept, maximum. Got lost in the middle there. So it's working. Like B is doing what we think it is, and that's good. Let's insert another one. So another problem, another graph page. I want to do sine of x, and then I already know what this one's going to do. Sine of x plus pi over 2 should shift it pi over 2 units to the left, because remember, it always goes kind of the opposite of how you think it should be. If it's like plus pi over 2, it's pi over 2 to the left. I always think that the starting point, which was 0, shifts to whatever makes the new set of parentheses equal 0. So you take x plus pi over 2, set it equal to 0. You get x equals negative pi over 2. You're shifting pi over 2 to the left. And you can kind of see that that's what happened. That's definitely what that's going to do. So I'm going to blow through the next one. Oh, wrong. I'm going to insert a problem, doc 4.1, a graph page. It's cosine of x. I'm really like, cosine's getting a raw deal here because I keep just kind of skipping it. I'm going to shift this pi units to the right. So pi to the right. Yeah, pretty much what I expected. And then the final transformation, we also already know, hopefully. So it's going to be sine of x, and then if I graph sine of x minus 2, you know this from like quadratics, right? So it just shifts, it's a vertical shift of 2 units. The sinusoidal axis is actually whatever the shift was, right? So we did sine of x minus 2. If I graph f of x equals negative 2, looks exactly like a new x-axis. The sinusoidal axis is the average of the maximum and the minimum. The amplitude is how far you can go up or down from the sinusoidal axis. And so if I did the next one, we would get the same result. So I think that we're probably good to try to summarize these, and then we'll probably call it a video. I mean, I don't know how long it's going to take me to summarize these because I take forever to do everything. But yeah, I was expecting that to go up 3. If I graph 3, I'm expecting it to cut straight through that graph. That is your sinusoidal axis. So the value of d actually does 2 things. It moves you up and down, and y equals d just straight up is the sinusoidal axis. So let's go back. The iPad actually fell asleep during all that. Got to show it my face so I can get in there. So here we go, back to the notes. We're going to summarize this, and then we will move on to the next thing. This is a big deal. Like there's so much going on here. So parameters A. All right. So we said the absolute value of A is the amplitude, and we said that you can go up or down A from the sinusoidal axis. Should I spell that? sinusoidal. I always abbreviate that SA. So you can move up and down A from the sinusoidal axis to get to the maximum and the minimum. That's what A is doing. Now, A also has another impact. If A is greater than 0, so actually, what do I want to do here? Then I'll say sine is going to go intercept, maximum, intercept, minimum, intercept. If A is less than 0, then sine will go intercept. So all the maximums and minimums just switch. So minimum, intercept, maximum, intercept. The sooner you memorize that pattern, the better. Cosine, right? Unit circle. At theta equals 0, you're at the point 1, 0. Cosine starts the biggest it will ever be. So it's maximum, intercept, minimum, intercept, maximum. And then if A is negative, cosine is going to go minimum, intercept, maximum, intercept, minimum. So A does a lot. And basically, they all do a lot. B, so we said the period of the graph. So this is like the big important one, is 2 pi divided by B. Technically, B will always be positive, because if B is negative, we'll use even and odd properties to just get rid of that negative. So either if it's sine, we'll kind of like factor the negative out. If it's cosine, we'll just kill the negative because cosine is even, so like it doesn't matter if that negative is there. So technically, B will always be positive. So the period of the graph is 2 pi over B. And then B is the number of cycles in 2 pi, right? And a cycle is the 5 key points. CY, how do you spell cycle? CYCLE, yeah, is 5 key points. So 1 full period is 1 cycle. It's how many you'll get in 2 pi, because 2 pi is the natural period. It should take 2 pi. The unit circle takes 2 pi to go around. That's basically where this is coming from. So then C is, so I'm going to say that x equals C is the starting point. So this will make more sense when we actually like graph some of the pattern or of a cycle. So it's the starting point of the pattern, and you shift horizontally. Horizontal shift of C units. Okay. So horizontal shift of C units. When I first started teaching 50 cent, I don't know how to say that, was a big deal. And he used to yell G unit a lot. So when I was teaching this, everyone would constantly kind of yell C unit. And that was weird. Anyway, D, we said, is a vertical shift of D units. So D could be positive or negative. Doesn't make a difference. And we said the sinusoidal axis, which we will now start abbreviating, is y equals D. And I mean, I'm going to say that's it. That's a ton. All right. So really, you got to get used to playing around with your calculator to investigate these things. But you have to know all of this. You'll know it, though. Like, don't just sit down and start memorizing this. You'll know it, because once we start graphing, it just gets into your head really fast. But you have to know this stuff to be able to graph. So like, I'm kind of going in circles on what I'm saying here. I'm saying don't memorize this right now, but be casually acquainted with it. And as we graph, you will become very aware of this, and it'll be easier to then memorize it. So anyway, I'm going to stop this here, come back in the next video, and do some more. So I will see you then.